Hello everyone. In this video you can get the solutions of module 1 for the model question paper 1 for the subject title BMATS201. So I welcome you all for SVK tutorials. So now we will see the solutions for module 1. Consider question number 1a. You have to evaluate triple integral integral 0 to a, integral 0 to x, integral 0 to x plus y, e power x plus y plus z, dz, dy, dx has been asked. We need to integrate thrice. So with respect to x, with respect to z first, as we have the limits here 0 to x and y, so this will be stands here with respect to z. Then here we have after integration of with respect to z, so the z term will be eliminated. You are left out with x and y. So next the limits containing is 0 to x. With respect to y they are asking, so therefore I need to integrate with respect to y. And finally you are left out with the constant limits that should be integrated with respect to x. This is what the way to write down the limits we have written according to the given problem. If they have interchange, you need to see the limits and then we can integrate with respect to that variable. So now integrating that with respect to z first. So we know integral of e power ax. What is integral of e power ax? It is e power ax divided by derivative of ax is a. So this is the way of integration of e power ax. But in this case we have e power x plus y plus z. So we can have loss of exponential. You can consider e power x plus y as it is and multiplied with e power z. I have applied loss of exponential. So then I can integrate just e power z. I will be concentrating on the term containing e power z. So I can integrate with respect to z. So once I integrate with respect to z this term, so integral of e power x plus y plus z will be an e power x plus y plus z divided by 1. Divided by 1. So that is what I have written here. So hence I will put the limits as z equal to 0 to x plus y for that. So in place of z you are going to substitute x plus y and lower limit as 0. So this is what the substitution, e power x plus y plus x plus y minus of e power x plus y plus 0. In place of z I have substituted. So now simplify this. X plus x becomes 2x, y plus y becomes 2y, x plus x 2x, y plus y 2y. So it becomes e power 2x plus 2y minus e power x plus y dy dx. Next integrate with respect to y. As I told you, integral of e power ax is what? E power ax divided by a, right? So similarly, now I will be concentrating the term on y, that's all. So I will be integrating this whole term. It will be retained as it is. E power 2x will be constant. So e power 2x plus 2y divided by derivative of 2y. Differentiation of 2y is what? 2. That is what I have written. Minus, similarly, e power x plus y derivative integration is what? E power x plus y divided by derivative of y with respect to y is 1. So substitute the limit, integral limits y equal to 0 to x. So after substitution you are going to get this. So after simplification we are going to get e power 4x minus e power 2x minus of e power 2x minus e power x. So then expand this. I will multiply minus sign inside. So it will be minus e power 2x minus into minus plus e power x. Here we have minus 1 by 2 times of e power 2x minus 1. So that becomes minus 3 by 2 minus 3 by 2 e power 2x. So finally you are left out with respect to x. Integrate that with respect to x. We are going to get 1 by 2 times of e power 4x divided by 4. Integral of e power 4x is what? E power 4x divided by 4 minus 3 by 2 is constant. Here integral of e power 2x is e power 2x divided by 2 plus integral of e power x is what? E power x limit x equal to 0 to a. Now substitute the limits, upper limit minus lower limit. go with upper limit for the first term, or else you can go with first substituting the upper limit for all the term, then go with minus of lower term. Anyway, you can solve the solution. Substituting for x equal to a, e power 4a by 2 into 4, it is 8. So I have taken out 1 over 8 common. So e power 4a minus e power 0. E power 4a minus e power 0. E power 0 value is 1. So that's why I have written here 1. Minus 3 by 4. So how we got 3 by 4? 2 into 2 is 4. 3 by 4 is constant. Substitute the limits. E power 2a minus e power 0 is 1. So plus similarly e power a minus 1 you are going to get. So now collecting the term containing a alone, e power 4a by 8 minus 3 by 4 e power 2a plus e power a, minus of taking minus common. So here minus, as I am taking minus common, you are left out with what? My plus 1 minus 3 by 4 was multiplied with minus 1, that become plus 3 by 4. So as I am taking minus common here, you are left out with minus 3 by 4. Here plus 1 is there, as I am taking minus 1 common. So finally you are left out with the constant terms. This simplifying that, what we are going to get, the value of I is this. So minus 3 by 8 is the constant term. So simplifying that part, we are going to get the final solution. So this is the way of solving triple integral. So they may ask a triple integral or double integral. So moving on to question number 1b. Evaluate integral 0 to infinity, e power minus of x square plus y square dx dy by changing it to polar coordinates. This problem is very much important. Don't neglect this problem, since they have been asked this problem so many times. So try to concentrate on this problem and study well. So they are asked to, they have given double integration and they are asking to change this Cartesian form to polar form. So for that reason, we will go with consider the given problem. We go with standard substitution of polar coordinates, that is x equal to r cos theta, y equal to r sin theta. So once I substitute x equal to r cos theta, y equal to r sin theta, x square plus y square will be r square. So substitute x equal to r cos theta, it will be r square cos square theta plus y equal to r square sin square theta, r square cos square theta plus r square sin square theta. Taking r square common, you are left out with r square into cos square theta plus sin square theta, that will be 1. So that's why it is equal to r square. So then dx dy will be similarly, if you differentiate, you are going to get dx dy as r dr d theta. So now I need to find the range, as they have given the limits. X ranges from 0 to infinity, y ranges from 0 to infinity. Now I need to change it into polar coordinates. So it becomes r and theta. I need to find the limits now. As r is ranging from 0 to infinity, the polar coordinates x, y becomes what here? This point becomes p of r comma theta. P of r comma theta. So for that reason, r in this quadrant, r is ranging from 0 to infinity. R is ranging from 0 to infinity. But the theta is in the first quadrant. R is theta will be ranging from 0 to pi by 2. Only the range of in the first quadrant, the range of theta is 0 to pi by 2. That is what I have written here. R ranges from 0 to infinity. Theta ranges from 0 to pi by 2. Substituting that in the above integral, therefore I becomes integral theta equal to 0 to pi by 2, r equal to 0 to infinity, e power minus of x square plus y square. X square plus y square is what here? R square. That is what I have substituted. And dx dy is what? R dr d theta. That is what I have substituted. Now I need to integrate this. For that integration, I am going with the substitution. So r square, this method is called substitution method. Put r square equal to t, and differentiate this with respect to t. What we are going to get? 2r dr by dt, which is equal to 1. So try to get the value of r dr. So as I can substitute r dr value here. So r dr will be what? Dt, as we cross multiply dt here. Dt into 1 is dt divided by 2. Cross multiply 2 here. So that becomes dt by 2. So t will also ranges from, as I am changing r to t will also ranges from 0 to infinity. Therefore, the integration becomes what? Theta equal to 0 to pi by 2 integral t equal to 0 to infinity e power minus t, as I am substituting r square equal to t, and r dr will be dt by 2 d theta. So you can take out 1 by 2 common and integrate e power minus t with respect to t. Integral of e power minus t with respect to t is my e power minus t by minus 1. Limit, substitute the limit, t ranges from 0 to infinity. So once I substitute the limit, it becomes what? E power minus infinity minus e power 0. E power minus infinity value is 0 and e power minus 0 value is 1. So I have substituted 0 minus 1. I got 0 minus 1 d theta. 0 minus 1 is minus 1. Minus 1 into minus 1 by 2 is plus 1 by 2. So therefore integral 0 to pi by 2 into 1 d theta. If I integrate with respect to theta, that's enough. We will get the solution. So integral of 1 with respect to theta, integral of any constant with respect to that variable will be an that same variable. So therefore I am integrating with respect to theta. So it will be theta. So put the limit theta equal to 0 to pi by 2. So 1 by, now substituting the limit here, pi by 2 minus 0 will be an pi by 2 into 1 by 2 will become pi by 4 is the required solution. Moving on to the next question. Question number 1c. Show that the question is on beta and gamma function. As standard proof they have been asked. Show that beta of m comma n is equal to gamma of m into gamma of n divided by gamma of m plus n. So you can also refer my previous videos that I have been already explained this video. So you can go through my previous video, which is solutions of model question paper of previous semesters. So same thing I have been explained. So you need to consider the definition of beta of m comma n and name that as equation 1, gamma of n, name that as equation 2, gamma of m plus n. So from equation 2 and 3, I can get gamma of m into gamma of n. That will be 4 times of integral 0 to infinity e power. I am going to add the basis of both equation 2 and 3. I am going to get e power minus of x square plus y square, x power 2n minus 1, y power 2m minus 1 dx dy. So go with the substitution of polar form. So x equal to r cos theta, y equal to r sin theta. So after substitution, we are going to get this expression. So after getting this expression, so we will segregate the term containing r. So as we have r power 2n minus 1 into r power 2m minus 1 into r. So applying laws of indices, I am going to get r power 2m plus 2n minus 1. Similarly, sin power 2m minus 1 theta into cos power 2n minus 1 theta d theta. Next, I will separate the term containing r and theta. So I will be getting the integral values like this. So as I have mentioned in equation 4 and 1, so I can rewrite that integral value as gamma of m plus n into beta of m comma n. I required beta of m comma n. I will cross multiply that. So remaining term. So I am going to get beta of m comma n as gamma of m into gamma of n divided by gamma of m plus n is the required solution. So this problem is also very important for your point of your examination. Moving on to the next question, that is evaluate integral. This is a choice question. You can consider the question number 1 or consider the question number 2. So in this they have been asked evaluate integral 0 to a integral y equal to a x by x square plus y square dx dy by changing the order of integration. In question number 1, A, they have been asked double or triple evaluation of double or triple integral. But in question number 2A, they will be asking changing the order of integration. Or they may ask question number 1A itself changing the order of integration, or they may ask question number 2A here. So that depends on the question paper set. So moving on to the solution. So consider the given value I. So name the given unknown as I equal to integral 0 to a integral 0 to y to a x by x square plus y square dx dy. Now I need to define the limits here for which variable it stands. As we have dx here, the limit should contain y here. So the limit is y. So we can consider this limit stand for x. Similarly, you are left out with another variable called y. So this limit stands for y. Now I will trace this. Now I will trace this limits in a graph in a pictorial representation. I can go with a now. Now I can go with the pictorial representation of this limits. So that is, as x is ranging from y to a, consider the line x equal to y. This is the line I have considered, x equal to y. Then consider the line x equal to a. This is the line x equal to a, x equal to a. Then we have y equal to 0 to a. So y equal to 0 is x-axis, y equal to 0 to a, up to a, y equal to a I have drawn. So this is the line. So overlap uh, from y-axis from y from limit y. When I consider y equal to 0 to a is the range. So the overlapped region was this. Now I need to change this order to x to y as they were given x to y. Now I need to change the order to y to x. So for that reason, I will consider first x ranges from 0 to a now. Now I will consider the boundary of this boundary. So the boundary is x is equal to a and the y will be the bounded region is equal to a. So that is what I have x equal to 0 to a 0 x. So substituting this after changing the order of integration, substitute the values above. So we are going to get integral x equal to 0 to a, y equal to 0 to x divided by x square plus y square dy dx. So integrate with respect to y first. So integral of, we know what is integral of 1 over a square plus x square. So which is nothing but 1 by a into tan inverse of x by a. So using this standard integral formula, you can have you will be having a formula booklet. So you can make use of formula handbook. So there these formula will be provided. Make use of that. So here a will be x here. So therefore it is 1 over x into tan inverse of y by x. So here x get cancelled. You are left out with tan inverse of y by x. Will be left out with integral 0 to a tan inverse y by x. So substitute the limit as y ranges from 0 to x. So when I put y equal to x, so this becomes x by x. So tan inverse of 1 minus when I give y equal to 0, so it is tan inverse 0. So tan inverse tan inverse 1 is pi by 4 and tan inverse 0 value is 0. So you are left out with pi by 4 dx. Integrate pi by 4 x. So anyhow pi by 4 is a constant. Integral of with respect to that constant function is, we are going to get constant variable called x. Substitute the limits So limits is 0 to a, upper limit a minus 0, a minus 0 is a. Finally, the answer is a by 4. Moving on to next problem, that is question number 2b. Using double integration, find the area of a plate in the form of a quadrant of the ellipse x square by a square plus y square by b square equal to 1. So this is the general formula, a general problem. So they can also ask by giving an double integration solution. Directly they have given as a generalized formula. We need to solve this problem by using double integration. Means what they may provide means they will provide find the area of ellipse by using the double integration x dy dx, like this they can provide, or like double integration y dx dy they can provide, like this. So anything, any of this kinds they can be provided, but in this case they have not provided anything. So directly you need to solve the find the area of the ellipse using the quadrant. So first I raise the graph. So this is the graph I have considered. This is the ellipse. So in the first quadrant I have considered the I have shaded the first quadrant part. So as the first quadrant is symmetric to second quadrant, and the second quadrant is to third, third is to fourth. So therefore, I can say that if I consider only first quadrant, I can multiply by 4 times of first quadrant. That will be the area of the given ellipse. So for that reason, after considering the ellipse, I need to know what is the range of the first quadrant. Here the x-axis always represents y, y-axis always represents x equal to 0. That's why I represent y equal to 0, x equal to 0 as x-axis. Then the limit here, this line starts with always x equal to 0. This line will be y equal to a. So I need to find the region here. So as they have given, as I have considered, area equal to 4 times of double integral over region R dx dy. I need to find the boundary first. The boundary is y equal to 0, y equal to 0 to y equal to, this is the boundary I have taken, y equal to 0 to y equal to b I have taken. So this is the boundary. Next, the whatever the bounded region. So this is what the bounded region in that part. So shaded part. So the shaded part is what? X equal to 0 to the curve called parabola. The curve called what? Ellipse. So ellipse is defined as what? X square by y square a square plus y square by b square equal to 1. Solve for x. So I am going to get a by b square root of b square minus a y square. So this is what the limit I am going to get. The range y equal to 0 to b, and x ranges from 0 to a by b square root of b square minus a square. Substituting that limits here, substitute that limits and further go with integration. So integrating with respect to x, I am going to get integral y equal to 0 to b x into integral from y equal to 0 to b. Integrating, as I am integrating with respect to x, as we have constant of 1, integral of 1 is x limit 0 to a by b square root of b square minus y square dy. Substitute this limit, upper limit minus lower limit, as upper limit is non-zero, minus lower limit is 0. So non-zero minus 0 will be a non-zero value. So that is what I have written, a by b square root of b square minus y square. So now I need to integrate this with respect to y. So which is given by, I have taken out constant term a by b. Integral, we are left out with integral y equal to 0 to b square root of b square minus y square dy. I think you will be having a handbook. The formula is a standard formula. Integral of square root of a square minus x square dx will be always equal to a by 2 into square root of a square minus x square plus a square divided by 2 into sine inverse of x by a. So the same manner here a value stands with and x is what here y. X is what y. So just substituted over according to this formula. I am going to get this. Then substitute the limits as y ranges from 0 to b. If I substitute upper limit b square minus b square will be 0. Lower limit is y 0 into any real value is 0. So you can just consider this value and substitute that the limits upper limit. But I've done for both the things. See, first I have substituted upper limit here. So b square minus b square will be 0. That's why I have 0. I substitute the upper limit here. b by b becomes 1. So b square by 2 times the sin plus y square minus lower limit is 0 plus b square by 2 sin plus 2. Sin inverse of 0 value is what? 0. Sin inverse of 1 value is what? Pi by 2. So you are left with b square by 2 into pi by 2 multiplied with the constant a by b. Here, one b term can be cancelled as we have with this product term. So we can cancel product of any two terms here. Hence, when we have a fraction, we can cancel product of those two terms. So b by b get cancelled. You are left with one more b. So the final answer is pi a by 4. Pi a by 4 is the required answer. So this is the way of answering the module 1. So whichever the problem is comfortable to you, choose that choice properly in your exam and solve this. Now I feel that you are all comfortable to solve module 1. So uh, choose the problem easily, and this module is very easy to solve. Don't get panic. So you can score easily minimum 14 marks in this module. You can refer my previous video. I told you how to choose the problem. Choose the perfect one and solve easily. I think you all understood how to solve these things. And if you like this video, kindly do subscribe to my YouTube channel and share this video with your friends. So also I will be sharing this PDF file in description. You can download this PDF file. I thank you all for watching this video.